We then go into the 3D printing in curriculum base for schools. That's inventing in 3D. These are all prototypes. It's very important in designing. How to apply CATDesigns into education project-based works, which means to say in the school itself, there's always concerns that they want to achieve a certain target, a certain project. The CATDesigns will actually help the children for the first 6 months into understanding how to actually think in 3 dimensions. And then likewise, the project will be incorporated to bring this out into physical objects. Entrepreneurship, how to turn your ideas into business. It is how you see your ideas and how you apply the concept of business that creates your idea into a real business. Okay? It's to how you apply design thinking into your ideas and business is so important, because if you don't have the right concept in it, or your focus, like the dark room, remember? The flashlight, you get lost. If you are focused and with 3 laser beams guiding you, you are more than likely not to succeed. It's a pinpoint design thinking. Okay, now I'll go into the process, the system and the process of how you actually learn. It starts with the school. Okay? The kindergarten, primary, secondary, college, poly, IT, and university is based on enrichment classes, inside and inside the school itself, in-house and inside the school itself. It's based on the 4 pillars. The 2D to 3D AR systems, we have 28 of which I will show you only one. There are 28 systems of how you turn 2-dimensional to 3-dimensional. But I will show you only one today because of time limit. And the 3D printers, how it's incorporated into the design thinking. With the curriculum project base, it is the most important part because it's hands-on. It's experimental learning. That's where ideas generates itself. Everybody, teamwork, operating on a project will actually create more ideas. And then the entrepreneur part, the business part. Why you don't do certain things in order for you to achieve the entrepreneur part. Okay, so in design thinking, you have to do all this. Okay, can a genius be taught? Controversial? Answer ultimately is yes. Some say 10,000 rule applies. For those who know the 10,000 rule, it applies, which means you have to put 10,000 hours of work in it. Others disagree and it says the intensity of how you actually do it. How focused are you at it? Okay? So basically, if you are focused, you don't actually require this 10,000 rule. And the next one is the most important as well, opportunity. Opportunity actually creates a product into the world, or brings a product into the world. Without opportunity, if you don't know how to get opportunity, your product will never come out into the world. What's the last one, the third one? Actually, is the most important of all. Okay? And what else is required? So I'll show you this later as I go through the process. Within your folders, you will have this, on the third page, I believe, 4 dots. And the 4 dots is 4 red dots. It's like your 4 dots that's in the vision and mission. But here it is in a piece of paper, 2 dimensions. And these 4 red dots, how many shapes can you create by using 1, 2, 3, or all 4 red dots? The most important word here is create. Okay? And how many designs can you create by using 1, 2, 3, 4 red dots? And it's also create, but this is in designs. The first one is shapes, the second one is designs. And then what else can you do with these red dots? So this is the beginning of the process of thinking out of the box. You have actually 30 seconds to think of simple shapes that you can create with these 4 red dots, and then designs likewise. And keep it with yourself. And see how many you can actually achieve. In the meantime, I'll take a break. 10 seconds. Three, two, one. Okay, let's go to the next slide. The next slide will be the most important slide. You would like to be an inventor, you would like to think out of the box in any industry. The next slide is going to be the most important. This is the process of how you actually think out of the box. It starts with kindergarten level and it goes all the way up to university level. What I'm about to show you is basically kindergarten, primary school level. Okay, these are the possibilities, but it's only 5% or less of the possibilities. Okay, what I'm about to show you is on the first level. These are your two-dimensional possibilities. Trapezium, triangle, triangle on the side, triangle flat on the ground. How many of y'all managed to get those? If you did get it, excellent. On the second level, take the point and a line as the pin. A pin. Take the triangle as the target. The pin can come from the back of the triangle. The pin can come from the front of the triangle. The pin can come from above or likewise below. It is orientation. It is how you actually see a product in 3 dimensions. It's the orientation of the design. So as to see that you are able to solve things like the concave curve. If you can't see the bamboo pole touching the metal holder and likewise the plastic, you can't see the solution. So this is part of it. Every invention is copied from somewhere else. So where did we get ours? It's simple designs like this. It's the cylinder and the oval. It is how you bend and reshape the cylinder and the oval. It gets you 11 features to solve a problem. So never underestimate simplicity. In itself, simplicity is the most complex thing to create. To create a simple product, like our Prime Minister mentioned to me, Charles, it looks very simple. It takes a lot of complexities, and it all starts with simplicity. Okay? On the next level is creativity. How you place your lines to create direction. Can be an arrow on the left, arrow on the right, tripod. This is creativity taking place. The beginning of seeing things that is no longer in 2 dimensions. And then you go to the next. You create further across an X, an N, a C, the possibilities. You can create letters with dots. And at the end of it, if you are a child, and if you go beyond the statement of what was mentioned earlier, and if you create a shadow below the object, it shows you. Someone else will probably teach you and tell you, no, you not actually follow the instructions. And our viewpoint is excellent work. You are the exceptional few. Those who can see and do beyond what the instruction is given is the beginning of thinking out of the box. It is because you follow the instructions, it limits you. It puts you in a dark room. It bounds you to the ground whereby you are unable to think. But the moment you go beyond the instructions, and then all you see is possibilities. So possibilities and imagination is very important. And now I'll show you what the schools normally teach. 3 dots. 1, 2, 3 numbers, alphabets. Formulate a triangle, 2 dimensions. I've asked many people before, can you draw a car for me? That's what they draw. A 2-dimensional image of a car. And the question is, why? Why are you drawing a 2-dimensional image of a car when every car I see out there is in 3D? 3 dimensions. Remember that. Your left brain and your right brain, are they connected? Yes, they are. Are they working together? No, they are not. You have been taught to follow the line, the instructions. You are excellent for the left brain. But your limited capacity of your creativity is on your right side. Okay? we create the balance. We bring you up on the creativity side. So how do we do that? And this is just red dots. Just one of 28 systems. Just 25% of what we teach for the red dots itself. Okay, we throw in an additional dot, the fourth dot. The fourth dot is where you go in from 2D to 3D. We throw in a line, and the line says, we give you that, so that you understand the depth of field. Teachers will likewise tell you, you have to follow the line 1, 2, 3, 4, then you go up and down. And we tell you, no, we don't follow the line. What is the fastest way to move from point A to point B? He will tell you, a straight line. Is that true? No, it's never true. Up to a certain point it is true, but guess what? Nature doesn't have a straight line. Never. Have you ever seen a straight line in nature? Not on Earth, not in space. So what system does nature use? Okay, this is important. The least root of resistance is the fastest way to move from one point to another. And what is the least root of resistance? In other words, the child draws a triangle in 3 dimensions. It doesn't matter which way he hits it, as long as he hits it. So that is part of the thinking process. You have to go beyond. So going beyond is, you're teaching them how to draw in 3D. You're teaching them how to color as well in gradient format, not basic format of plain colors, in gradient format. Gradient format creates a scenery like a sun rising. And in this scenery you see of the 2 pyramids and the sun rising, we also incorporate errors in the object or the image. Okay, this is to see how they can actually spot the errors and see how they actually can think. If you can look at the 2 pyramids